This one's a bit tricky, I believe. All right, but you probably have to see a bit of a pattern over here. All right. So how does it work? Okay, 1,2-diol treated with dilute acid, the protonated diol undergoes pinnacle rearrangement as shown. Which of the following products is not formed by this rearrangement? Okay, so maybe I think I'm going to show you roughly the mechanism. So how you end up getting this product here. Okay, let's see how it's done. So you started with a diol, right? With a diol. Okay, so what it means is this. Maybe I just show you very quickly how this works. Okay, you started with a diol here. Okay, diol here. So in the presence of acid, okay, in the presence of dilute acid, they say this is what happens. Right, I put a H plus over here first. Okay, let me just change it a bit. Okay, so you get the CH3, COH, CH3. Okay, there's a lone pair, this O that takes in the H plus, that's why they drew it this way. You can see there's a H. So the H plus actually, the lone pair goes to H plus and then the O takes the positive charge. Alright. Okay, the next step, what really happens is this. What they're trying to show is this. Okay, maybe just to give you some idea. The OH bond here, there's a OH bond. Sorry, I'm just going to change it a bit. Okay, there's an OH bond over here. Right, the electrons, actually I can take it as the electrons from here goes here, electrons from here goes here. Alright, so what do you end up getting? Okay, what do you end up getting? And over here, I think the electrons from here will go to the O. See, there's a plus over here. Alright, so let me just draw it out. You get CH3, a C double bond O. Alright, then this is CH3, this is CH3, and this carbon become a plus. Alright, and water is being formed. Okay, see that? And this guy here actually becomes CH3 minus. So since this CH3 minus will attack this carbon, and then you actually end up with the product, which is CH3 double bond O, CH3, CH3, and CH3. Can you see that? Okay. So but to cut a long story short, I just need you to be able to see what's happening. So you have to, your eyes focus on the 2 carbon with the OH. What you need to do is pull out one of the CH3 that's attached to the carbon, or one of the R groups attached to carbon, and put it on the other carbon. Okay, so this CH3 actually goes here. You see that? And on this carbon, all right, you take away water, take away OH, all right, and this side will form a O double bond C. Okay, so let's try. So let's see how we did this one. How you get A. A can be obtained. Okay, A can be obtained when this OH is being kicked out, all right, and the CH3 goes to this carbon. Okay, so it's like you kick out, is the same concept over here. All right, let's leave this question. You have to see a bit of pattern. You kick out the OH from here, and then this CH3 goes to the adjacent carbon, right? So this CH3 goes to this carbon, and you kick out the OH, all right, and then this one becomes double bond O. Okay, so this is how you got the first one. Can you see that? Okay, let's try the next one. Okay, must be able to see a pattern here. Okay, for the second one, you actually kick out this CH3. It goes to this carbon, all right, and then this OH was gone, and then also this one forms the C double bond O. Okay, so that's why you get this structure. Okay, that's why you get this structure. All right. Okay, let's look at the next one, how you end up getting C. Okay, is it possible to get C? Okay, is it possible to get C? Yes, it's actually possible to get C. So very quickly, all right, this is a bit more tricky. I hope you can tell. Okay, this whole group, right, this whole part, this carbon, okay, this carbon was, this whole part was kicked out, all right, and it actually went to this carbon. Okay, went to this carbon. Can you see that? So the part that you kick out the CH3, all right, this part will become a double bond O here. Okay, you can see this is going to form a double bond O, and then this OH will be kicked out. Okay, this OH should be kicked out and this carbon will actually join to this carbon. So if you try to draw it out, it looks like that. It's a bit I'm going to draw the untidy form first, right? So this one, the double bond O, see? And this carbon here will join to this carbon. You see that? So now this becomes CH2, CH3, and this is actually CH3. Okay, so this is what's happening. All right, this is actually what's happening. So if you look at it carefully here, I want you to see a pattern here. In this ring, there's how many carbon? 1, 2, 3, 4, 5, 6. You see? So that's why this structure here, I want you to look at it very carefully. It's actually really this structure over here. All right, it's actually this structure over here. Okay, so the answer is actually D. This cannot be formed. All right, this cannot be formed. Okay, you have to, maybe some of you might have to have a bit of you must spend a bit more time looking at this and see whether you can get the answer. Okay, this is a bit more tricky, this question, right? It's for you to see whether see a pattern and see whether you can derive from the options given. Okay, so that's how we do question 17.